Hello everyone, welcome to my channel. If you have not already subscribed to my channel, please do subscribe to my channel. Today's topic is about macro facility interaction with the call execute. And this is part 9 of SAS Macro Series. Now let us briefly look into call execute. Here I will give a very general introduction about call execute, and more on this we will look into and try to understand with the help of code. Now call execute is a data step function. Call execute, what it does is it allows us to pass character string to macro facility for immediate execution during data step. This point is very important to know. Whenever we try to mix macro facility and data step, what will happen generally is macro facility generally runs first, and this is due to macro triggers ampersand and percent. And we have discussed in detail about this topic in the very first video of SAS Macro Series, that is SAS Macro Series Introduction. Now, what call execute does is call execute allows us to interact a data step with macros facility, and how this happens we will discuss in detail with the code. And now there is one another important point here is whenever there are SAS statements generated during call execute, they are stacked in input stack, which will run once the current data step completes. These 2 points are very important to know in the call execute. So most of the time the problem comes with the call execute is understanding the timing. With this brief introduction, let's try to look into the code and try to understand call execute more. Now let us try to understand call execute with a very simple example. In here I'm highlighting my example. In this example, we do not have any macro reference. I have taken this simple example to explain how call execute works. In here, if you look into, we have a data step in which we are saying data underscore null underscore, and we are saying then call execute, and in the parenthesis we are having a code, and in this code we are writing proc print data equal to SAS help.class semicolon run semicolon, and then I'm closing my quote and also my parenthesis. And what will happen is once I run this code, it will generate a SAS statement. This SAS statement will be saved in input stack. And once the data step is completed, then only this SAS statement gets executed. Now let us try to quickly run this piece of code, and here we can see our result. This is not very important, but let's quickly go into the log. And in the log, if you see, we have our data step in here, and in here it shows that this data step is complete. And once this data step is complete, we can see a note wherein it says call execute generated line, and this line is nothing more than proc print data equal to SAS help.class semicolon run semicolon. And in here this particular statement was generated during data step, but it got executed only after data step is complete. And now let us try to understand this little bit more with the help of an example which is a little bit more useful to us. Here this is super simple, rarely we use this kind of thing for call execute. Now in here I have a data set. In this data set I have a variable, and the variable name is DSN, and I have three observations in here. The first one is SAS help.class, second one is SAS help.class, third one is SAS help.air. My goal here is to generate statement as follows: proc print data equal to SAS help.class semicolon run semicolon, and then I want to generate proc print data equal to SAS help.class semicolon run semicolon, and same with the SAS help.air. Now what we can do for this is simple. In here we are again using data step to generate the lines we want. And in here I am saying set P, that is from this data set wherein we have three observations. And in here what I am doing is using a set statement, I am saying set P. And also I am doing a call execute. And I want you to focus here. This call execute which I have earlier discussed and this call execute is very similar except one change. Here what we are doing is I am directly writing SAS help.class and this generates this proc print statement, wherein what I am doing here is I am writing everything up till in here in quotes, and then for this part SAS help.class part, what I am doing is I am concatenating with DSN variable, and the DSN variable value comes from this data set, and the remaining semicolon to run semicolon again is the same, and again I am concatenating it with this DSN. So let's see what is happening in here. So when SAS reads the first observation, this DSN will become SAS help.class. Whole of this statement will become proc print data equal to SAS help.class semicolon run semicolon. This SAS statement will be generated and it will be stored. And then it reads SAS help.cars and this becomes proc print data equal to SAS help.cars semicolon run semicolon, and then again it reads the third observation and this does proc print data equal to SAS help.air run semicolon. And if you see in this fashion we are reading each observation and then we are able to dynamically create SAS statements. Here, because we have three observations, we have created three proc prints, and one important thing to remember here is all of these three statements generated will be stored in the input stack. And one another important thing to remember is all of these three statements will be executed one after another once data step is complete. Now let us quickly try to run this and see what is happening in here. And let's quickly look into the log to understand this better, and what is happening exactly we can only know from the log. Here, if you see, first we have created our data set and everything was clean, and then we have run our call execute. If you see here, it shows that this data step is complete. If you see in here, we can see that the first SAS statement which was generated during data step got executed, and we can also see about it in the results in here. And also once we go little bit down, we can see that the second SAS statement also has been executed, followed by the third SAS statements. We need to understand that the SAS statements got generated during data step, and once the data step is complete, all the SAS statements which were in the input stack execute one after another. Now, till now we have seen what happens when SAS statements are generated during call execute. But now let us quickly look into what really happens when no SAS statements are generated during data step. Here I have a data step wherein I am saying data underscore null underscore, and in here I have set SAS help.class. And in the call execute, what I am doing is I am doing %put and name is in single quotes. The important point I want you to remember is I have kept the whole of this thing in single quotes. Why is this important? If I have put this in the double quotes, what would have happened is this %put would have executed even before the data step starts, because these percent and ampersand are macro triggers, and when they are in double quotes they execute immediately. So what will happen is this step executes immediately even before reading anything from SAS help.class. Now let us see how this whole thing works. In here, as I have written, percent put name is in single quotes, and I am concatenating it with name variable which is there in SAS help.class. First, what will happen is the first observation in the SAS help.class will be read, and the name variable has the value of Alfred here, and the text in here will become percent put name is Alfred. And if you can see in here, there is no SAS statement in here. When I say SAS statement like proc print or any data step, there is nothing of that sort. So what will happen is this will execute immediately. So this percent put will put the value of name is Alfred into the log, and then what will happen is it will read the second observation. The second observation, I know the value of variable name is Alice. So what will happen in here is the same thing which we have seen before, and this puts the value of name is Alice into the log. And if you can see in here, in the same fashion, it will be reading each and every observation in SAS help.class, and it will get executed immediately. And now let us quickly run this and see what happens in here. In the note here, you can see that call execute routine executed successfully, but no SAS statements were generated. This you can generally see after our data step completion. But if you see in here closely, all our put statements, or rather I would say percent put statements, have been executed, and they are here, they are well before our data step completion. For example, if I would have added another call execute, and in that call execute, if I would have added something which creates SAS statements, then what would have happened is I would have had these values in here and all the SAS statements after my data step completion, but I have not done that to keep it simple. The important point to remember is call execute executes immediately when there is no SAS statement. But if there are SAS statements, what will happen is they are stacked up and they are kept in input stack, and once the data step is complete, all of those SAS statements get executed. So there is a timing difference when there is SAS statement created and when there is no SAS statement created. Till now, we have been looking and trying to understand how the call execute works. But till now, we have not tried to look into how call execute interacts with the macro facility. Now let us look into that aspect. To understand this concept, what we need to do is we need to look into an example. Now, to understand this example, let's quickly look into this data step. But before the data step, I would like to explain what we want to do in here. In here, the target is to create data set from each name in SAS help.class. So I want to create a data set from each name in SAS help.class. One way to do it is write something like this: data Alfred set SAS help.class where name equal to, in quotes, Alfred semicolon run semicolon, and this creates Alfred data set. And to create Alice data set, all I need to do is I need to change in here and also where name equal to Alice. Instead of writing all of these 19 names in here and here to create 19 data sets from SAS help.class, why I'm saying 19 data set is I know that SAS has 19 different names and we can create 19 data sets. Instead of that, we can create a simple macro, something like this, wherein I am writing percent macro test, and in the parenthesis I am writing nm equal to, and then in here what I am doing is I am mentioning data ampersand nm set SAS where name equal to ampersand nm in the double quotes, run semicolon, and then I'm closing this macro. So once we create this macro, what I can do is I can pass Alfred, Elise, and each name. But the problem with this kind of approach is I have to pass each name. Even though I'm not writing a lot of code again and again and again to create data sets, but I have to pass parameters over and over again. And this is not efficient. And this kind of problems are more easily solved in a dynamic fashion, wherein we do not pass parameters but we bring it from a data set. These kind of things can be solved by using proc into clause and also followed by a percent do loop in a macro, or by using calls input and then using a percent do loop. And I have discussed about how to do that in one of my videos of proc into clause, and link for the same I will give in the description below. But whenever we want to do those kind of things, the code becomes little bit more complex. That is, first we have to create macro variables and then we have to use do loops. But these kind of things can be easily solved using call execute. Now let us see how we can do this thing using call execute. Now in here what I am trying to do here is I am having my data step wherein I am using a set statement and I am mentioning SAS help.class. And in here if you see, what we are doing is we are using call execute. And this call execute is going to generate these macro calls. And how is that happening is, in the single quote I'm using percent test, which is very similar to this, and also I'm using parenthesis and name equal to in here in quotes, very similar to what we have in here. The Alfred comes from this SAS help.class when we read the first observation, and then I'm also adding this ending parenthesis with the help of concatenation, and then I'm adding this part. So in a way I'm generating this statement. In the same fashion, after reading each observation, we are going to change our parameter and generate this statement. And in here important thing to remember here is this macro has a SAS statement. So this gets executed only after data step is complete. And to understand this, now let us quickly try to compile this macro. And now let us also quickly run this data step which is called execute. And in here you can see that 19 data sets were created. And let's also quickly look into the log to understand this better. In here you can see that our data step is complete in here. After the data step is completed, you can see that call execute has executed first SAS statement which was created during data step, that is this one, and after that it has executed second SAS statement which was created. So here you can also see the numbers 1, 2. In that fashion you can see that 19 SAS statements are executed one after another with the help of call execute. And now what I want to explain from whole of this is, instead of using proc equal into clause or calls input and then trying to run %do loop, that is whenever we want to do dynamic programming. Whenever I use the word dynamic programming in these particular cases is using data set and achieving what we want to achieve without giving any manual input. So a data driven programs when we want to create, which again we can say in here as dynamic programming, we can use call execute, and call execute the code is much simpler. Now that we have looked into call execute, now let's look into what are the challenges which are posed by call execute. To understand the challenges, we need to run a different macro in here. Here I have a macro and this macro is test2. The striking or important factor or important thing about this macro is I have a data step in this macro, and also I have percent put statement wherein I have a macro variable reference. So if I want to execute this macro with the help of call execute, here I need to be focusing on two things. The first one is the data step, which is a SAS statement. This does not run till this data step is completed. But the macro references and things which do not have SAS statements get executed immediately. So let us quickly compile this macro, and let me also quickly run this call execute. Here we see a warning. Before going into the warning, let me tell you one another thing, that is, this gets executed immediately, this gets executed later. That is after data step is complete. After this data step complete, only then this part of SAS statement runs. But this runs immediately as we have macro reference in here and there is no SAS statement in here. So because this has run immediately after I have ran this particular call execute wherein I am executing this macro, what will happen is this ampersand macvar is a macro variable which is created in the step above, but this runs even before that. So we get a warning saying that this particular macro variable is not resolved, because if you see in here, this has executed immediately. That is, this part of our macro has been executed immediately. But if you see in here, our data step has run much later. So whenever you have macro reference without any SAS statement, it gets executed immediately. And anything related to SAS statements runs later. So here there is a timing issue. So you need to be very careful of that when you are trying to have macro references and SAS statements in a macro, and if you are executing through a call execute. Now there are ways to handle that and we will discuss that in a minute. Before going to do that, let me also quickly delete the macro variable which we have created in here. The problem with the calls input in this particular scenario is it creates a global macro variable, and this is a special case of global macro variables getting created in a macro. More on this topic I will discuss when I talk about scope of macro variables, which would be my next part of my macro series. And in here, let me delete the macro variable by saying %simdel and giving the macro variable name followed by semicolon. As we have created global macro variable in here, I am deleting it, and deletion of the macro variable is successful. So we no longer have our macro variable present in our session because we have deleted this global macro variable. One way to address this issue of timing is by simply using nrstr. So whenever you have macro references and you want to use along with the call execute, you always need to either use %nrstr, or there is another way to do it, but I will discuss that later. So what this %nrstr does is it delays the macro execution itself. So nothing get executed, unlike in here wherein it got executed in the data step itself, and then this got executed first because it did not had any SAS statement and it has a macro reference. In here it delays the macro execution itself. Now let us quickly run this. In here you can see that nothing has happened up before the data step is completed, but after the data step the macro gets executed and everything gets executed in the order it was there in the macro. First this gets executed, then this gets executed. That is what we can see in the log also in here. I've also used mprint and it shows the SAS statement was generated first, and then the another %put statement which was there with the macro reference was done next. That is in the order it was available in this macro itself. So nrstr helps with timing issue. Another one which helps us with the timing issue is dosubl. Dosubl is a new function wherein it has properties of call execute, and also it addresses the macro reference timing issues. For this, the code is pretty simple. Instead of call execute, I am saying in here rc equal to dosubl, and then I am giving exactly the same what I have in here and then closing with the parenthesis. One important thing to remember here is, here I have mentioned rc equal to and then I am using dosubl, and whatever I want to have in here I am putting in the parenthesis in here. The important thing to remember here is this rc could be anything. This is a simple assignment statement. And now let us quickly run this. Before doing that, let us delete the macro variable by using %simdel macvar, and this deletes our macro variable macvar. And after that, let's quickly run our data step which has dosubl. Once I run this, here first I see that our data step runs first and then our macro reference works next. What do I mean by that is it exactly runs the way the code is set up in my macro. So there is no timing issue with dosubl also. So to sum it up, whenever we have macro references along with SAS statements, we need to be careful. We need to either use %nrstr or dosubl to address the timing issues. That's all for this topic. If you like this topic, please give it a thumbs up, share, subscribe, and thank you.